Yes, good morning everybody and welcome to today's tutorial. In the previous video we did our schematic in KiCAD, and this is the point where we reached, where we had a schematic and in our schematic there are several of things that we had not done, but we have to do them today. And for example, I'll explain a few things about this schematic, a few things like design annotation. Here, when you come to this point, we have a design annotation, annotating the schematic. When you place components, for example, let's place one component here. When you place components like this one, and you place it like this, these components come with a symbol that has a question mark, like this one you can see. But when you do annotation of this, you'll find that this question mark will disappear and get replaced by a number. For example, for this U1, because you have another U here, which is now U1, we will realize that this one will be converted now to U2. These are making components have unique identification. You see, annotated AD82 as U2, annotation complete. So you close and you check. You can see it's already annotated. So that's what is the importance of annotation in our design. And apart from annotation, we can check at design rule check. Design rule check is to make sure that your design conforms to all engineering rules. For example, you will get warnings here if you have some of the things that have not been done correctly. But when you have a serious mistake, you will find errors here. So when we run our schematic like that, we find it's finished, but we have 3 warnings. Warnings are not that dangerous, but we can remove these warnings. They have given you what you do. So pin 1, PW input of component 09 is not driven, so PWR. So what you do, you add what you call a power flag. So you can place component called the power flag, PWR, this one power flag, to remove such errors. So we have this one point here, and then copy this one, then we move to the next point. You can rotate it for it to fit nicely here. You add it there, then you can copy it again. So we don't have any other highlighted point, so you can control save and then check again to see if you have removed all the errors. You run again, there's still one pin that is not, it's here, so you can copy this one, copy, then you come and place it at that point. You can control save. After that, you can again come and try to check at those design rule errors. You run again, you can see 0 warnings and everything is finished. So you can create a report if you need one. Yes, and then when you run, you have it, you can save it. Default editor not found, you can stop that one. So you come and close. So you have our schematic, which is perfectly laid. The next point you go is you add some footprints. Footprints are very important because they will help us when we get to PCB layout windows. So you will need to add some footprints to your schematic. Okay, so it's not, let it load. Then we add some footprints. Still loading. Exactly. Now, I had already added some footprints to this schematic, but we can still check at them how they are added. So this one is a capacitor. So you come here, you search for the point where you get a capacitor. For example, this capacitor, but I can still delete the footprints. So I can still delete some footprints here so that I can demonstrate how to add them. Okay, connector, I can still delete some footprints. Okay, now after deleting, we can still try to add. Footprints are divided into 2. We have SMD. For example, look at this switch. We have button switch SMD. We have button switch THT. SMD stands for surface mount devices and THT stands for through hole technology. Surface mount devices means any component that you pick from this section of SMD, you will mount it on the surface of your board. So you place it on the surface and then you do the soldering. And then for THT, it means any component you pick from here, you will place it through hole. You drill a hole on your board, place it, and then solder from the bottom side. So let's look at surface mount, how it looks like. We can use the easiest component, which is a capacitor. Look at a surface mount capacitor. Come here, view selected footprint, and then you come at this point and do view the 3D display. You look at it, SMD, there is no any drilled hole on it. The component is placed on the surface and then soldered. You look at the pad, then it is soldered like that, positive and then negative. And then we go to the through hole technology on the same capacitors. It's here. Look at this one. Okay, let's open it, the 3D. Let's view the 3D. Look at it. Look at it. It has a hole drilled in it. Now, the reason why we utilize surface mount devices is because they are very tiny, they are compact, and they will make your design look neatly, very small, very compact, very miniature. But when you use through hole technology, expect to have a very big circuit. But again, it is very advantageous because you will have a strong joint as compared to SMD. So through hole technology, when you are doing an SMD device, it cannot be purely SMD. You have to mix because some things that require a lot of power, like the pin socket connectors, they should be through hole for them to give us a strong joint that we deserve. So let's start feeding this. We start with capacitor. I'll take SMD and I'll take electrolytic. So you double click. You see it's loading. You double click again. For S3, I'll use SMD, but I'll go for a code. I'll use 0805. Let's have a look at it. 0805 is here, 2012 metric. Let's check out how it looks like. Ready. You can look, it's SMD, it's a capacitor still, but now these are the modern types of capacitors that have been introduced in the market. Like that. For the connectors, I'll go for the connectors. I'll look for pin connector. I'll go for 2mm pin connector, which is somewhat bigger, and I'll go for the horizontal one. So you look at it. Okay, the review. This is the horizontal one, but we still have the vertical one. That's how it looks like. For the vertical one, this is how it looks like. The pin is vertical, but I like using horizontal pins. Okay, let me check out this one again. How it looks like. Okay, this one again horizontal, but you can see how it looks like. So I would like to use the horizontal one, like that, like that. So that's how to add the footprints to a schematic. So then you apply, and then you click OK to save it. Okay, sometime you might want to look for an electric symbol of a component. Let's look, for example, let's place one. You want to apply STM32. You want to apply STM32. This is the recent one. This one I have created it by myself, so I can still delete it. No, I should not delete it because I'll use it to explain. But yep, I will use it to explain. So you come to this point. You want to place a component. So STM32, for example, STM32. So I created this compound. I created it. You see, recently used. It's recently used. I created it and used it, but I have not saved it. So I want an STM32 footprints that looks like this. But again, when you come to all the symbols that you are getting here, you don't get what you require. So what you do, okay, you can click escape without placing it. You create your own symbol. You come to this point here, and then you hit this one. Then you go to library, create a new, so you can see it's empty. I will pick this one, so you can come and press symbol. Then you go to new library, it has 0 footprint. Then I create STM 32 32.0.31 F, and so on and so on. So I'll just guess the name. Then I'll move this one up. You start setting your system. Move again this one. You'll select symbol reference like that. Okay, you have it. Now you start placing your pins. These are I'm supposed to do a 32 pin. You see STM32. It means 32 pins. But I'm not going to do a 32 pins because for illustration purposes I'll use very few pins for this. So I might use even 3 pins for each side. So you start placing the pins like that. So this one I can call it VDD to be our first pin. Okay, let me check. Yes, our first pin. So it should be pin number 1. Hit OK. Then I rotate it like that. I place it there as a pin number 1. I go for pin number 2, XT1, which is pin number 2, like that. I go for pin number 3, which is XT0, and it's our pin number 3, like that. And then we go for pin number 4. And pin number 4, I'll call it A1. Pin number 4, like that. I'm going to use just 12 pins for illustration on how to do the symbol. Then I'll go for pin number 5, which is A2. Pin number 5. Okay. And then I'll go for pin number 6, which is our VSS. VSS, and this is pin number 6. Okay. I'll go to other pins. I'll go to pin number 7 and call it I'll call it VDD. This is our pin number 7. Okay, I'll hit OK. Place it like that. Then I'll go for pin number 8, which is our I'll call it, I'll label it SWDO SWDI0, and then is our pin number 8 of R for rotation. Is our pin number 8, and then pin number, I'll call it B1, and this one is pin number 9. Okay, I'll hit OK and place it there. But this VDD was supposed to be, so I can move it, like that. I can rotate R. It's supposed to be here. So I can continue. You can continue to place another pin. So we go to pin, and then I place it, and this one now I'll call it our pin number B1. You can call it B2, and then it's pin number 10, like that. Okay, can rotate it R. You can reduce these ones, and then I can place pin number 11, which is B3. Then it is pin number 12. You can number 11, and hit it OK. Place it there. Then the final pin number 12, you can call it VSS, and it's pin number 12. Hit it OK. Here we go. You can move this one, move again, so that the numbers, and then you can edit this one, and this one is pin number 8. And then now we can start to arrange our symbol to look neatly. So this one I can move it. Before I move it, I can come to this edge, and try to create something different here. Sorry. So that I can see the center. So I can move these ones, move these ones to the center. These ones already in the center. Run in the center, so the one remaining was this one. Move this one. Control save. So this is our symbol, and this is how to do symbols. So let's go to library and place symbols. We see whether our symbol is there. A. So we have created our symbol, so we can search for it, STM32. We created it in the new library, you can see. Okay, this is our symbol, the one that you have created recently. You can see our symbol is there. But again, we can still come here and place another symbol we had created. Let's look at it. That one was STM. Okay, you can say that one. STM32. Or you can search it in new library. New library. You can see we have two symbols. The one we had created earlier and the one that I have created right now. STM320.1F. Let's come here and look at what we have saved. STM320.1F, exactly the symbol that we need. So this one is what we have created right now, and we can place it. And there we go. That's our symbol. That's how to do symbols, your own symbols in KiCAD. And I think for today we have learned enough. We have learned how to annotate a schematic. We have learned how to do or to perform electrical rule check. We have learned how to assign PCB footprint to schematic symbols. And we have learned the big animal in the house, which is how to do a footprint, or how to design your own footprint when you are not happy with the footprints in the library. So today's video ends there, and let's meet next time, whereby we shall be doing now the actual PCB layout. We shall be doing the 3D design of our 5 volts power supply output. Thank you and goodbye.